Dear students, in this video, let us discuss Karl Pearson's coefficient of correlation. As you all know, correlation coefficient or coefficient of correlation will help you to find out the relationship between the two variables. Karl Pearson's coefficient of correlation was named so because it was suggested by this concept was the formula model was developed by Karl Pearson, who lived between 1867 to 1936. He was a great biometrician and statistician of Great Britain, and he has suggested a mathematical model of formula for measuring the magnitude of relationship between two variables. So it is denoted by Karl Pearson's coefficient of correlation is denoted by small letter r. The interpretations of Karl Pearson's coefficient of correlation is like this. A positive value of r, say for example 0.4, indicates a positive correlation. A negative value of, say for example, minus 0.4 indicates a negative correlation. Similarly, if r is equal to plus 1, the correlation is perfect negative. If r is minus 1, the correlation is perfect negative. And similarly, fifth one, if r is 0, the variables are unrelated. That means there is no correlation between the variables. Then if r is greater than 0.5 or equal to 0.5, then the correlation will be of higher degree. For example, if the correlation is plus 0.57, so it says that there is a strong positive correlation between the variables. Similarly, if the correlation coefficient is minus 0.75, even there it indicates that there is a strong negative correlation. Okay, now let us move on to discuss the models or the methods computation of coefficient of correlation. Okay, first let us take the raw data. So in case of raw data, like we can use the actual mean as well as the assumed mean. Under actual mean method, the correlation is r is equal to summation xy, small letter xy, divided by root of summation small x square into summation small y square. So what are the x and y, small letter x and y? Small letter x is equal to x minus x bar and y is equal to y minus y bar. When the deviations are taken from assumed mean, the model is a little different. So r is equal to n into summation dx dy minus summation dx into summation dy whole divided by square root of n into summation dx square minus summation dx whole square into root of n into summation dy square minus summation dy whole square. So here dx and dy are the difference between the x variable and y variable and their respective assumed mean. So dx is equal to x minus assumed mean of x series and dy means y minus assumed mean of y series. Let us work out a problem. Calculate Karl Pearson's coefficient of correlation between the age of husband and wife. So age of the husband is given in the first column, and age of the wife is given in the second column. Okay, now let us take age of husband as x and age of wife as. Okay, we will follow the first method, that is actual mean method. You can also work out this problem by using the second method, that is assumed mean method. Okay, the formula is r is equal to summation xy divided by root of summation x square into summation y square. Okay, now for this we need x and y, but to find out x and y we need x bar and y bar. Okay, let us go with the respective calculation. So for that, the first we need is x series. Okay, x series is the age of husband and the sum of x series is 310. Now we can find out the mean of x, age of husband. 310 divided by 10 is equal to 31. Now we can find out x minus x bar. So this column shows you the x minus x bar values and the summation of x is equal to 0. Now we can find out x square. This column shows you the x square values and the sum of x square is equal to 188. Now we'll move on to calculate y bar. For that we need the y series, age of y, and the sum of y is equal to capital letter Y is equal to 260. Now we can find out y bar, which is equal to summation y divided by n. So here summation y is equal to 260 and n is equal to 10. So mean is 26. So now we can find out y minus y bar. So this column gives you the y minus y bar, and so that now we can find out y square. So this column shows you the y square values, and so last one required for the formula is xy. So here we can multiply small x into small y. So the small x into small y, the sum of that is 188. Now we can substitute the values to the formula. R is equal to summation xy into divided by root of summation x square into y square. So summation xy is equal to 188 divided by square root of summation x square also 188, and summation y square also 188. So therefore R is equal to 188 divided by 188 is equal to R is equal to 1 now. Okay, this is the solution for the first problem where R is equal to perfectly positive correlation. Now computation of coefficient of correlation for grouped data. This is the model. R is equal to n into summation f dx into dy minus summation f dx into summation f dy whole divided by square root of n into summation f dx square minus summation f dx whole square into root of n into summation f dy square minus summation f dy whole square. Okay, so here dx is equal to x minus assumed mean of x series, and dy is equal to y minus assumed mean of y. This is the problem. Calculate coefficient of correlation between the marks obtained by a batch of 100 students in history and economics as given below. So in the one series, in the vertical part, in the first column, the history of marks is given, and in the horizontal form, the marks in economics is given. So marks in history 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, and marks in economics 30 to 40, 40 to 50, 50 to 60, 30, 60 to 70, 70 to 80, and therefore the total is given in the last column. Okay, now the number of students who have scored between 20 to 30 in history and 30 to 40 in economics are 9. Similarly, history 20 to 30, but in economics between 40 to 50 are 2, and in history 20 to 30, and marks in economics 50 to 68. Then marks in history 20 to 30, but in marks in economics 30 to 40, there are 4 students, and 20 to 30 in history and 70 to 80 in economics, there are 2 students. So total number of students who have scored marks between 20 to 30 in history is 25. Similarly, the history, the 30 to 40, there are 3 students who have scored 30 to 40, but and they have also scored 30 to 40 in economics. Then the students who have scored 30 to 40, but 40 to 50 in economics, there are 3. Again, 30 to 40 in history, but 50 to 60 in economics, there are 4 students. Then 30 to 40 in history, but 60 to 70 in economics, there are 6 students. Then 30 to 40 in history and 70 to 80 in economics, there are 3 students. So therefore marks in history 30 to 40, there are 19 students. Similarly, 40 to 50 in history, there are 2 students and who have scored between 30 to 40 in economics, and 40 to 50 in history, there are 4 students and they have also scored 40 to 50 in economics. Students who have scored 40 to 50 in history, there are 6 students, and in economics they have scored 50 to 60. Then 40 to 50 in history, there are 7 students and who have scored 60 to 70 in economics. Then 40 to 50 in history and 70 to 80 in economics, there are 4 students, and therefore total number of students who have scored 40 to 50, 23. Then 50 to 60, there is only one student who scored 50 to 60 in economics, and he has scored 30 to 14 economics, and the 50 to 16 economics, there are 2 students who have scored 40 to 15 economics. 50 to 16 history, there are 3 students who have scored also 50 to 16 economics too. Then 50 to 16 history, and they have scored 60 to 17 economics 3. 50 to 16 history, but they have scored 70 to 18 economics. There are 2 students, and therefore 50 to 60 who have scored in 50 to 16 history, there are 11 students, and 60 to 70 there are 5 students in 5 students under 60 to 70 who have scored 30 to 14 economics. 60 to 70 again, there are 4 students who have scored 40 to 15 economics. 60 to 17 in history, whereas in economics they have scored 50 to 60. 60 to 17 history, whereas they have scored 60 to 17 economics too. And 60 to 17 history, whereas in economics they have scored 70 to 8. There are 1 student, there is only 1 student. So total number of students who have scored 60 to 70 in history is like 22. Now look at the last row. This shows the number of students who have scored marks between 30 to 40. There are 20 students. Marks in economics between 40 to 50, 15. 50 to 60, 29. 60 to 70, there are 24 students, and 70 to 8, there are 12 students. So total number of students in a class 100. Now let us move on to solve this problem. This is minus 7 and minus 14. Okay, divided by n 100 into summation f dx square 167 minus this one, yeah, summation f dx x square, x is equal to minus 7 square into this one. So here n, this is summation f dy square 218 minus inside the bracket. So here summation dy square is equal to minus 14 square. So we'll when you go with this step, so we'll get these values, and finally we have a value of r is equal to 0.037. There is a weak positive correlation between the variables.